Hello and welcome to Almost Earth, a quiet corner where wonder lingers and science takes its time to breathe. Tonight, we're not chasing the birth of the universe or predicting its end. Instead, we're turning our gaze downward into the soil beneath our feet to ask a question that feels simple but shakes the ground beneath it. What if we weren't the first? Not the first to think, to build, to dream. What if eons before pyramids, satellites, or late-night science channels, another civilization once flourished here of this world, grown complex and then erased? I'm not speaking of mythical continents or visitors from the stars, but of something truly terrestrial, an intelligent biological species that rose and vanished so long ago, the Earth itself may have forgotten it ever lived. It sounds like the opening line of a sci-fi novel, doesn't it? Yet the idea is rooted in real scientific discussion, unwhispered in geology labs, and hinted at in quiet corners of cosmology conferences. The point isn't that we'll uncover skyscrapers beneath Antarctic ice or circuit boards trapped in ancient coal. The mystery runs deeper. If an advanced civilization had existed millions of years before us, would we even know? Could any trace endure the slow, grinding machinery of the planet's geology? Or would everything, our buildings, our tools, our bones, be folded back into stone and soil, until no line distinguished us from nature itself? Before we descend through these layers of time, I'd like to ask you something lighter. Where in the world are you listening from? And what hour finds you now? Strange, isn't it? We're speaking of ancient epics, yet here we are, bound for a moment by sound, by curiosity, by this small, shared stillness. If this kind of question, the kind that burns softly, is your kind of question, feel free to follow along. It helps this quiet signal drift a little farther into the world's noise. No pressure, just an open path, like faint footprints in dust leading somewhere unexpected. So let yourself settle. Maybe lie back. Let your thoughts slow until they move like continents. Tonight, we'll look backward, not through the short span of recorded history, but through the crust and silence of deep time itself. Before we can ask who might have come before, we need to understand just how vast time truly is, and how skilled this planet is at erasing. When we speak of ancient history, we usually mean a few thousand years, the age of pharaohs, the builders of Stonehenge, the first clay scripts. Even stretching to humanity's dawn, we reach only 10 or 12,000 years, a blink on the geologic clock, closer to today than to most of Earth's past. Yet it feels ancient enough to fill libraries with mystery and argument. But Earth is unimaginably old. Not millions, but billions of years, around 4.5, give or take a few hundred million. Through most of that vastness, there were no people, no mammals. For ages, no life on land at all, only drifting cells in dark oceans, evolving unseen. It was then, in that apparent emptiness, that most of our planet's story was written, layer by layer, stone by stone. The Earth forgets quickly. It does not keep diaries. Wood decays, metal rusts, bones dissolve, and time itself acts it, buries, melts, folds, and grinds. Mountains rise and crumble. Oceans open and vanish. Continents drift and collide, reshaping the face of the world every few 100 million years. When you think of it that way, survival any survival, beyond a few million years is a miracle. So imagine, just for thought's sake, 100 million years ago, long after dinosaurs ruled, yet long before they fell, an intelligent life form emerged. Perhaps upright, perhaps not. Maybe it walked the land. Maybe it swam the seas. Maybe it didn't build with stone or steel. Maybe it used things we'd never recognize as technology at all. Maybe it thrived, created, dreamed, and then, slowly or suddenly, was gone. Now, here we stand, millions of years later, asking whether we would ever know it existed. Because here's the uncomfortable truth. Permanence is an illusion. Even we, with all our towers and satellites, are as temporary as footprints in wet clay, waiting for the next tide of time to wash them away. Our towers, roads, libraries, and satellites, none of them are designed to outlast the patience of geology. Leave a modern city untouched for a few hundred years, and nature begins to reclaim it. Give it a few thousand more, and the outlines blur until you'd hardly guess people had ever lived there. Stretch that to a few million years, and erosion, tectonics, and subduction rewrite the surface entirely. Land becomes seabed, mountains crumble to dust, and almost every trace of us disappears. That isn't imagination. It's what geology and archaeology already show us. Even evidence of recent prehistoric humans is incredibly scarce, not because our ancestors were idle, but because Earth is an expert in renewal. The fossil record tells the same story. Patchy, fragmented, full of silence. Not due to a lack of life, but because fossilization requires a perfect storm of coincidences, rapid burial, mineral replacement, shelter from erosion, and a measure of luck. Most creatures that die never fossilize. They rot, are eaten, or dissolve. And even if a fossil forms, the rock must survive long enough to be found again. Now multiply that by tens of millions of years, you start to understand how fragile permanence truly is. It's not only bones that vanish. Buildings decay, tools corrode, metals oxidize, and plastics break apart under sunlight or soil. Concrete itself, if left alone, eventually fractures and fades. So, if there had been another civilization in Earth's deep past, especially one that built lightly, without endless stone monuments, we might never know it existed. And yet, someone has asked this question seriously. In 2018, two scientists, Gavin Schmidt and Adam Frank, explored this possibility in a research paper. They didn't claim that an ancient civilization truly existed. Their curiosity was methodological. If such a civilization had once risen and fallen, how could we tell? They called it the Silurian hypothesis, borrowing the name playfully from an old British sci-fi series about intelligent reptiles. Their real investigation was forensic. What geological fingerprints would an industrial civilization leave behind? What chemicals, isotopes, or synthetic molecules might endure silent signatures of technology in ancient rocks? They imagined working like detectives without a body, a weapon, or a witness, hoping the wallpaper itself might still whisper the story. And from that thought came an unsettling idea. Perhaps the absence of evidence isn't proof of absence. Perhaps this is what a planet looks like after it resets its surface every few 100 million years. Civilizations don't vanish neatly. They alter their world. They burn fuel, mine metals, grow crops, and scatter waste. But those fingerprints fade too. If another species had its own industrial age, something equivalent to ours, could we detect it now? Would subtle shifts in carbon, rare elements, or sediments still carry their echo? Maybe yes, maybe no. Even today, our own imprint is already being written into stone and sea. Scientists call this proposed epoch the Anthropocene, the age marked by human hands. Plastics in the oceans, concrete in the soil, nitrogen thickening the air, radioactive dust from nuclear tests. These are our global calling cards. If some distant future intelligence were to dig into our time, these might be the clues they'd find. But for how long would they last? And after millions of years, would anyone still recognize what they meant? This line of thinking isn't a fantasy. It sharpens scientific awareness. It forces us to confront what we can find and what we inevitably miss. The geological record is a jigsaw with missing pieces. Some ages are beautifully preserved, others nearly erased. Erosion scrapes away layers that took millions of years to form. Tectonics folds and buries whole continents. And then there's the ocean vast, concealing more than 70% of Earth's surface beneath miles of shifting water and sediment. Most of the planet's face is young by geological standards, renewed or reshaped within the last few 100 million years. Even the ocean floor is temporary. It's recycled through subduction, where old crust slides beneath continents and melts back into the mantle. So if an ancient civilization had once built its world near a coast, or upon an island long swallowed by the sea, its ruins would now rest in molten silence. And yet, here we are building, observing, recording. We ask if we're alone in the cosmos, but rarely wonder if we've ever been alone on Earth. Maybe the past was truly quiet, or maybe it's still speaking only in a language time has taught us to forget. Soon, we'll look closer at what could endure, what certainly couldn't, and whether some forgotten trace might already lie beneath our feet, waiting to be recognized. There's still more to unfold in this story, more layers, both literal and intellectual, and we'll move through them carefully, one by one. So let's pause, take a breath, and ask a simple question before wandering any further. What exactly are we trying to find? Before we can search for lost civilizations, we should agree on what the word even means. In everyday speech, civilization often conjures an image of something advanced, a society with cities, writing, government, and skylines. But that's a narrow modern lens. Even among humans, civilizations have taken wildly different forms and built monumental cities with roads and temples. Others left behind little more than a shared language or cultivated land. Yet we still call them civilization. Archaeology and anthropology handle the term with more precision. Researchers usually define civilizations by a constellation of traits: urban centers, specialized labor, centralized governance, agricultural surplus, organized belief systems, social hierarchy, symbolic writing or communication, and long-distance trade. These are the usual markers, but not every civilization checks every box, and some achieve complexity in ways that defy our expectations. So, when we entertain the idea of a forgotten civilization buried deep in time, we must widen the frame. We're not necessarily seeking pyramids or microchips. We're searching for signs of complexity, social, technological, ecological. patterns that do not arise by chance, evidence that a species organized itself at scale over time for reasons beyond survival. It helps to imagine civilization not as a destination, but as a continuum somewhere between basic subsistence and planetary transformation. On that spectrum, there's room for many possibilities. A culture of toolmakers, building structures that endured beyond their own lifetimes. A species capable of storing knowledge, passing it on, and reshaping its world deliberately. It may sound modest, but in evolutionary terms, that leap is immense. And if it happened more than once here or anywhere else, it's worth serious thought. Consider an example close to our own beginnings. The ancient settlement of Atal-Hik in what is now Turkey. It's roughly 9,000 years old, no streets, no monuments, no written language, just clusters of homes pressed tightly together, roof to roof, with entryways from above. And yet, it counts among humanity's earliest known cities. Because what matters isn't the skyline, it's the pattern. Coordinated architecture, continuity of settlement, ritual practice, food production, and collective memory. Even without grand monuments, such patterns reveal cooperation across generations. Go further back, and the traces grow faint. The first hints of symbolic thought appear in carved tools, pigments, and ornaments, objects that imply planning, reflection, maybe even belief. They're not technology in our modern sense, but they show technological thinking, minds working in abstraction. Now stretch that imagination further, 10,000 years, 10 million or 100 million. What would we expect to find from a civilization that old? The answer depends entirely on how it lived. If it built with organic materials, wood, fibers, haidas, those would vanish. If it practiced ritual without durable artifacts, bones might remain, but their meaning would be lost. If it had no writing or used symbols unlike any we recognize, its stories would fade completely. And if it inhabited regions hostile to preservation, rainforests, coasts, swamps, its physical memory would vanish in centuries, let alone in geological ages. That's not concealment, that's entropy. We must also beware of projection. We tend to equate intelligence with what we are: speech, tools, cities, and now digital code. But awareness could take entirely different shapes. A civilization might never industrialize at all. It could organize through behavior, chemistry, or visual patterns instead of architecture or machines. Its sophistication might lie in forms of communication we don't yet have names for, and that raises a haunting question. Would we even recognize such a civilization if we saw its remains? Think of a termite mound. To us, it's just a pile of soil. But look closer, it's an engineered structure with climate regulation, airflow, and food storage. Each mound is a city, the colony a collective organism, scaled up 1,000-fold or buried for a few million years. Even that masterpiece would blend into rock and dust. We'd mistake it for nature itself. There's still more to unfold in this story, more layers, both literal and intellectual, and we'll move through them carefully, one by one. So let's pause, take a breath, and ask a simple question before wandering any further. What exactly are we trying to find? Before we can search for lost civilizations, we should agree on what the word even means. In everyday speech, civilization often conjures an image of something advanced, a society with cities, writing, government, and skylines. But that's a narrow, modern lens. Even among humans, civilizations have taken wildly different forms. Some built monumental cities with roads and temples, others left behind little more than a shared language or cultivated land. Yet we still call them civilizations. Archaeology and anthropology handle the term with more precision. Researchers usually define civilizations by a constellation of traits: urban centers, specialized labor, centralized governance, agricultural surplus, organized belief systems, social hierarchy, symbolic writing or communication, and long-distance trade. These are the usual markers, but not every civilization checks every box, and some achieve complexity in ways that defy our expectations. So, when we entertain the idea of a forgotten civilization buried deep in time, we must widen the frame. We're not necessarily seeking pyramids or microchips. We're searching for signs of complexity, social, technological, ecological, patterns that do not arise by chance. Evidence that a species organized itself at scale, over time, for reasons beyond survival. It helps to imagine civilization not as a destination, but as a continuum somewhere between basic subsistence and planetary transformation. On that spectrum, there's room for many possibilities. A culture of tool makers, building structures that endured beyond their own lifetimes. A species capable of storing knowledge, passing it on, and reshaping its world deliberately. It may sound modest, but in evolutionary terms, that leap is immense. And if it happened more than once, here or anywhere else, it's worth serious thought. Consider an example close to our own beginnings: the ancient settlement of Atalhik in what is now Turkey. It's roughly 9,000 years old. No streets, no monuments, no written language. Just clusters of homes pressed tightly together, roof to roof, with entryways from above. And yet, it counts among humanity's earliest known cities. Because what matters isn't the skyline, it's the pattern. Coordinated architecture, continuity of settlement, ritual practice, food production, and collective memory. Even without grand monuments, such patterns reveal cooperation across generations. Go further back and the traces grow faint. The first hints of symbolic thought appear in carved tools, pigments, and ornaments, objects that imply planning, reflection, maybe even belief. They're not technology in our modern sense, but they show technological thinking, minds working in abstraction. Now stretch that imagination further, 10,000 years, 10 million or 100 million. What would we expect to find from a civilization that old? The answer depends entirely on how it lived. If it built with organic materials, wood, fibers, haidas, those would vanish. If it practiced ritual without durable artifacts, bones might remain. But their meaning would be lost. If it had no writing or used symbols unlike any we recognize, its stories would fade completely. And if it inhabited regions hostile to preservation, rainforests, coasts, swamps, its physical memory would vanish in centuries, let alone in geological ages. That's not concealment. That's entropy. We must also beware of projection. We tend to equate intelligence with what we are: speech, tools, cities, and now digital code. But awareness could take entirely different shapes. A civilization might never industrialize at all. It could organize through behavior, chemistry, or visual patterns instead of architecture or machines. Its sophistication might lie in forms of communication we don't yet have names for. And that raises a haunting question. Would we even recognize such a civilization if we saw its remains? Think of a termite mound. To us, it's just a pile of soil. But look closer, it's an engineered structure with climate regulation, airflow, and food storage. Each mound is a city, the colony a collective organism, scaled up 1,000-fold, or buried for a few million years. Even that masterpiece would blend into rock and dust, would mistake it for nature itself. When we think about lost civilizations, we have to borrow two mindsets, that of the archaeologist and that of the biologist. Because we're not just hunting for ruins or relics. We're searching for anomalies, disruptions in the normal rhythm of geology. Unexpected chemical traces, unusual mineral clusters, sediments that don't match natural processes, odd isotope ratios, small clues that whisper, something was here, doing something deliberate. There's also the matter of time. How long would a civilization need to exist before leaving a mark on the planet? Surprisingly, not long at all, not in geological terms. In only a few centuries of industrial activity, humans have altered nearly every system on Earth. From a sedimentary perspective, that's little more than a smudge. Yet the chemical consequences are enormous. Greenhouse gases, synthetic compounds, radioactive isotopes. Even if humanity vanished tomorrow, these fingerprints would echo for tens of thousands, maybe millions of years. So perhaps the real question isn't whether a prior civilization existed, but whether we'd even know how to recognize it. We tend to search for the familiar fossils, ruins, tools, signs that make sense to us. But what if the evidence were stranger, smaller, or hidden where we've never thought to look? To explore that properly, we need to think in epochs, not centuries. We have to study how the earth erases, what endures, and what fades away. Because to hide something forever, you don't need to destroy it or bury it deep. You only need to leave it on the surface and wait long enough for geology to breathe, shift, and consume. The earth is never still. It moves, it exhales, and it recycles everything built upon it. Given enough time, every monument, every city, even every mountain will disappear. From our short-lived perspective, that's hard to imagine. We grow up believing landscapes are permanent, mountains eternal, rivers steady, cities timeless. But to a geologist, the world is always in motion. Given sufficient time, even the hardest rock bends or flows, even the highest peaks crumble. The planet's surface is constantly rewritten, which means anything resting on it is, by nature, temporary. It starts small. Rain, wind, frost, sunlight, all working patiently. Cliffs wear away grain by grain. Roots pry open concrete. Metal rusts, organic matter decays. A few generations pass, and buildings collapse into ruins. A few more, and the ruins themselves become indistinguishable from the surrounding earth. Unless something extraordinary happens, rapid burial, extreme dryness, or deep freezing, those remains vanish entirely in geological terms. Then comes sedimentation, dust, sand, ash, soil. Layer by layer they settle, concealing whatever lies beneath. Sometimes that preserves artifacts or bones, other times it crushes and distorts them. Over millions of years, those layers compress into rock, and that buried city or skeleton might survive only as a faint imprint in limestone if it survives at all. Tectonics adds another layer of forgetfulness. Earth's crust isn't one smooth shell, but a restless mosaic of plates drifting atop molten rock. They crash together, split apart, and grind sideways. These movements raise mountains, trigger quakes, and drag whole seafloors back into the mantle. This process subduction is a kind of planetary recycling. Entire landscapes are drawn downward and melted, their records erased. The average age of the ocean floor is only about 200 million years ancient by human standards, but barely an instant on a 4.5 billion-year-old planet. That means most seafloor has been replaced again and again. If a civilization once lived near coasts or islands, its remnants might now be drifting far beneath our feet, dissolving into magma. Even the continents, which seem so stable, fail to preserve a perfect memory. Wind and water carve them down. Glaciers scrape them clean. Volcanoes bury them in fire. Forests come and go. Deserts wander. Rivers change their paths. Even massive impact craters, scars of cosmic violence, fade with time. What feels immovable to us is only a momentary balance in a long dance of motion. The Grand Canyon is often praised as a geological chronicle, layers of history stacked like pages of a book. But even that book has missing chapters, gaps where layers were never written, or were later torn away by erosion. Geologists call these absences unconformities, and they remind us that the Earth's memory is partial, a patchwork stitched from what happened to survive. Survival, in geology, is the rare exception. The fossil record, our main window into ancient life, is itself a story of absence. Most living things never fossilize at all. Even those that do are found only when erosion or accident reveals them. It's not that fossils are hiding everywhere. It's that most have long since been destroyed. The planet remembers only fragments, and the rest is gone for good. If that's true for bones, the literal remains of living things, it's even truer for the marks of culture. Tools, buildings, inscriptions, technology, even within our own species, whose artifacts are only tens of thousands of years old, what we usually uncover are fragments. A flint blade, a shard of pottery, a dark stain in ancient soil where a post once stood. From these scraps, archaeologists rebuild entire worlds, because that's all time allows to survive. So when we ask whether another civilization might have existed millions of years ago, the burden of proof becomes staggering. It's not merely that we haven't found their cities, it's that the odds of anything surviving that long are almost zero. And even if some fragment did endure, it would have to rest in a place untouched by subduction, erosion, or burial, a geological miracle. Think about how we search for asteroid craters. Massive impacts can leave scars hundreds of kilometers wide, yet even those fade. Over time, they erode, deform, vanish beneath sediment or sea. Sometimes we detect them only through gravity anomalies or through subtle distortions in mineral layers. Now imagine trying to find something smaller, a city, a sculpture, a factory floor. Unless preserved in a perfect protected niche, it would be almost invisible. And even then, someone would have to be looking with the right instruments in the right place, asking the right kind of question. Most fossil hunters aren't searching for intelligence. They're seeking species, bones, and ecosystems, not road networks or architecture. They read the sediments for signs of life and extinction, not civilization. And if a discovery doesn't resemble a tool or an artifact, if it looks too natural, it's likely to be dismissed as geology, not engineering. That bias is sensible. Nature itself builds intricate forms, crystal lattices, patterned erosion, mineral veins, spherical concretions. Without context, it's almost impossible to distinguish a natural formation from an artificial one. A perfect sphere could be a crafted ornament or a concretion formed by slow chemistry. Without surrounding clues, it's simply an oddity. This is why the Silurian hypothesis takes a different approach. Rather than looking for monuments or machines, it asks a subtler question. Could a long-vanished civilization have changed the planet's chemistry in a way we could still detect? Not what they built, but what effect they left behind. Even that is slippery. Because nature also changes chemistry. Volcanoes alter carbon cycles. Methane bursts reshape climates. Mass extinctions flood the record with unusual isotopes. Any one of these could mimic the signals of an industrial age. The challenge isn't just finding anomalies, it's interpreting them, knowing when the fingerprints belong to chance or intention. That takes humility, not because such an ancient civilization is likely, but because certainty itself is fragile when the evidence is mostly gone. We like to imagine history as a clean timeline, beginnings, middles, ends. But geology doesn't write in lines, it writes in layers. It cares for pressure, heat, erosion, and renewal. The planet constantly rewrites its own story, and most chapters are erased, not hidden, simply undone. Yet we're not finished here. If the Earth is this efficient at erasing, then the next question is obvious. What resists erasure? What endures not for centuries or millennia, but for millions of years? To answer that, well, turn to the quiet survivors, not fossils or monuments, but signals more subtle, more chemical than architectural, things more stubborn than stone. When people hear fossil, they imagine a complete skeleton laid neatly in rock, a creature turned whole to stone. But the truth is quieter. Real fossils are fragmented, compressed, distorted by time. They require extraordinary luck, very specific conditions, and endless patience. Even then, fossilization is an exception, not the norm. And the record it leaves is partial, full of silence, where life once moved. The fossil archive is one of our best tools for peering into deep time, but it's far from complete. It's like trying to reconstruct a film from a few torn frames and scattered subtitles. For every species we've found, countless others have vanished without a trace, some never fossilized, others destroyed, others still buried where we've never looked. That's the scale of absence we already face when studying known life. Now imagine applying that same uncertainty to civilizations we've never seen. Fossilization depends on impossible alignments, how and where something dies, the kind of sediment that buries it, the speed of burial, whether scavengers intervene, and whether tectonic forces later reveal or obliterate it. That's a lot of conditions to meet, and each one has to go perfectly right just once for something to last long enough for us to notice it at all. The odds are against preservation from the very beginning. For most of Earth's history, the habitats where life flourished, coastlines, floodplains, rainforests, were the worst possible places for anything to last. They were too active, too wet, too alive. Now imagine trying to preserve not bones, but the products of culture, tools, buildings, writing, infrastructure, things that begin life far less durable than shell or our bone. The chances shrink to almost nothing. Even stone tools, among the toughest relics we make, become difficult to recognize once they lose their context. A chipped stone could be an artifact or just a coincidence of fracture. Without a pattern of wear or nearby clues, it's impossible to be certain. And most other materials fare worse. Metal corrodes, fabric disintegrates. Plastic, unless sealed away from air and sunlight, eventually breaks apart. Even for our own ancestors, the record we hold is incomplete. Take Homo erectus species that walked the earth for nearly 2 million years. We have fragments of bone, hand axes, traces of fire. But much of their story is gone. They migrated widely, endured different climates, likely communicated and planned, but their beliefs, their social structures, their dreams all lost. Not because they left no evidence, but because the earth refused to keep it. When we excavate prehistory, we aren't digging up life as it was. We're uncovering survivors, the fortunate few whose remains landed in precisely the right conditions, buried quickly, spared from pressure and heat. That's why mass extinctions leave such bold lines in the rock record. A sudden die-off buries immense quantities of organic matter before decay can erase it. Ironically, the layers richest in fossils often correspond not to times of flourishing, but to moments of catastrophe. So, if traces of an intelligent species ever existed, we might only find them if they happen to live near one of these rare, preservation-friendly disasters, a very narrow window indeed. And that assumes they left bodies at all. Advanced beings might have practiced cremation, sky burials, or sea burials, methods that scatter rather than preserve. Or they might have transcended the biological altogether. What if a civilization advanced so far that it shed its organic form? What if thought itself migrated into artificial systems, distributed and synthetic? If that ever happened, the fossil record wouldn't just be silent. It would be meaningless. Even today, most of what we create is non-organic. Polymers, alloys, engineered compounds. To a geologist millions of years from now, the remnants of our world might appear as strange, chemical stratothin bands of titanium dust, specks of microplastic, traces of rare earth metals. Would anyone recognize them as evidence of civilization, or dismiss them as an anomaly of nature? Interpretation is as critical as discovery, and interpretation carries its own bias. Science sees what it's trained to see. The notion of a civilization that rose and vanished millions of years ago does not fit comfortably within most frameworks of geology or biology. So, unless the evidence were overwhelming, it would likely be catalogued as a natural oddity, not a sign of intelligence. That's not negligence, it's caution. Science favors the simplest explanation that fits the data, and vanished civilizations are never simple. This is why the fossil record, for all its wonder, can never tell the whole story. It shows only what the planet allowed to endure, what we happen to find, and what we're prepared to interpret. It tells us something about life, but not everything about mind. Still, there are other kinds of evidence signals that don't depend on bone or shell. Clues written not in shape but in chemistry. Changes in atmosphere, soil, or stone that record not organisms but processes. That's where we turn next, to the evidence that outlives biology, to the fingerprints intelligence leaves when it begins to alter its planet. In 2018, two scientists, Gavin Schmidt and Adam Frank Poe, said a question that was at once speculative and rigorously scientific. If an industrial civilization had existed long before humans, could we detect it in the geological record? They weren't suggesting that such a civilization had actually lived. Their aim was methodological, to understand how science would even look for one. They gave the idea a name, the Silurian hypothesis, borrowing playfully from an old British sci-fi story about ancient intelligent reptiles. But the hypothesis itself isn't fantasy. It's an exercise in humility. It asks whether the imprint we're leaving on Earth is truly unique or whether something like it could have happened before. The premise is straightforward. If an industrial civilization had risen 50 or 100 million years ago and then disappeared, what traces would remain? Could any survive erosion, burial, or tectonic upheaval? Schmidt and Frank began with what we already know, our own planetary footprint. We've altered the atmosphere's composition, changed ocean chemistry, and filled sediments with synthetic materials, plastics, fertilizers, industrial waste. These shifts are already being written into the crust of the Earth, forming what some scientists call the Anthropocene layer. So the real puzzle becomes, which of these traces endure the longest? And if similar traces existed deep in time, would we even recognize them as the work of an earlier intelligence? The researchers outlined several categories of possible evidence. One is geochemical anomalies, subtle shifts in stable isotope ratios like carbon, oxygen, and nitrogen. When fossil fuels burn, for instance, they change the isotopic balance of carbon, and that signal becomes locked into sediments and ice cores. If something like that appeared in rocks tens of millions of years old, it might hint at an ancient industrial process. Another is synthetic materials. Modern civilization produces plastics and chemical compounds unknown in nature. Many degrade slowly and could, in theory, persist in some altered form for eons. Already, microplastics have been found in ocean floors, mountain air, even Antarctic snow. If ancient layers held similar non-natural polymers, they would demand explanation. Then there's energy use, specifically the burning of carbon fuels. A civilization reliant on such energy would scatter coal ash, soot, and fly ash, leaving distinct chemical fingerprints, much like volcanic deposits. These could accumulate in layers, traceable long after the civilization itself was gone. And finally, there are mass extinctions, those sudden collapses in biodiversity that reset life's course. Sometimes natural, sometimes maybe not. Human activity has already accelerated the rate of extinction across countless species. That sudden collapse of biodiversity, especially among large animals, creates a distinct biological scar in the fossil record. If something like it appeared deep in time, without an asteroid strike or supervolcano to blame, it might hint at an industrial hand behind the change. But that's where the trail gets slippery. Nature can write the same signature we do. Take the Paleocene-Eocene thermal maximum, about 56 million years ago. A global fever that raised temperatures, acidified the oceans, and scrambled the carbon cycle. The rocks from that era carry some of the very same chemical imbalances we're etching into the planet right now. As far as we know, no civilization caused that. So how can we tell the difference between a natural upheaval and one born of intelligence? That is the hardest question of all. The Silurian hypothesis never claims we've found evidence of a forgotten civilization. It simply asks whether we would recognize such evidence if it existed. And more provocatively, it asks us to look at our own reflection. What traces are we leaving? And how long will they last? Even our most durable signatures, plastics, radioactive isotopes, industrial residues, aren't immortal. They can break down, sink beneath new strata, or vanish into the mantle as continents drift and recycle themselves. A few fragments might endure, scattered and cryptic, but without context, they'd be nearly impossible to read. This shifts the focus. Instead of searching for ruins and monuments, we must think like planetary archaeologists. The clues worth chasing are subtle. Faint chemical distortions, strange sediment layers, ecological disruptions that whisper of design. We also need humility, the willingness to admit that some of the oddities already recorded in Earth's strata could have other interpretations. This isn't a call to myth-making or conspiracy. It's a scientific framework, a way of refining the questions we ask. Like any hypothesis, it stands or falls by evidence, and it can be tested, debated, and improved. But it also invites a deeper reflection. If a species as pervasive as ours could still vanish geologically unnoticed, how many others might have already risen and disappeared, lost not through insignificance, but through the patience of Earth and the completeness of time? The Silurian hypothesis doesn't say someone came before us, only that, if they did, their footprints would be faint. And in that faintness lies a challenge: to imagine what signs endure, how to read them, and what such a discovery would mean for how we see ourselves in the planet's long memory. Because if those traces exist, they won't appear as temples or texts. They'll lie hidden in rocks, in chemical residues, in thin seams of unfamiliar compounds. And that leads to an unsettling thought. What if we've already found such clues, but didn't recognize them for what they were? So let's turn the lens inward. If tomorrow, every human being simply vanished, no war, no disaster, just absence, what would the Earth look like without us? A year later, cities would still glow for a while. Cars would sit exactly where they stopped. Planes would wait in silence on their runways, but the machinery of civilization needs caretakers. Within months, the power grids would darken, water pressure would fail, and steel would begin to rust, not through apocalypse, but through neglect. Within a few years, nature would begin to repossess the world. Seeds carried by wind would root in pavement cracks. Vines would climb glass towers. Sidewalks would heave as roots pushed upward. Animals would return, first the small ones, then the cautious grazers, and finally the predators. Forests would spread through suburbs. Rivers would reclaim their floodplains. The earth would not mourn us. It would simply breathe again, as it always has, and in that renewal lies the quiet truth of geology. Everything that stands eventually falls, and every trace we leave becomes part of something else. Without us, the boundary between wild and built would dissolve almost immediately. In cities like New York or Shanghai, the subways would flood within days once the pumps went silent. Steel would bloom with rust. Glass would fracture. Within decades, towers would fall in on themselves, especially in damp climates where concrete breathes and breaks. Though it feels eternal, concrete is fragile, its steel veins corrode, cracks spread, weight shifts, and what once seemed immortal crumbles. Roads would last a little longer, but plants would pry through asphalt, roots breaking it apart, grain by grain. Bridges, deprived of maintenance and paint, would weaken, joints would fail, and they too would fall. Above us, satellites would wink out one by one as their batteries died and solar panels darkened. Most would spiral downward, burning into the atmosphere, while a few distant relics would remain, drifting quietly through the void. After 1,000 years, nearly all signs of our presence would be unrecognizable. Skyscrapers collapsed, steel reverted to dust-red powder, plastics shattered into microscopic fragments. Underground cables and pipes would corrode to nothing. From above, faint outlines of roads or cities might still trace the landscape, ghostly scars etched into desert and tundra, but little more. After 10,000 years, even those scars would fade. Forests would reclaim the temperate zones. Deserts would wander, burying what we left behind. Erosion would redraw the coasts we once knew. Only a few relic stone carvings, mountains reshaped by our hands, might persist a little longer. Mount Rushmore's faces softened, the pyramids sinking inch by inch beneath the sand. 100,000 years on, almost every structure would be gone. Only what lies deep mine shafts, landfills, layers of altered soil might whisper faintly of us. Even these would be crushed, filled, or hidden. Their meaning, if any remained, would be indecipherable without context. After 1,000,000 years, very little would survive. Maybe a handful of sealed vaults, buried waste repositories, or molecular traces locked in ice. Maybe lakebeds or ocean sediments, recording subtle spikes, carbon, nitrogen, plastics, rare earth elements. These would be the true fossils of civilization. Not statues, but chemistry. Not monuments, but signatures. If humanity vanished tomorrow, Earth would begin erasing us at once, not deliberately, but by design. Erosion, biology, tectonic, each doing its quiet work. And with every cycle, the evidence would fade until even the idea of us became uncertain. This isn't just philosophy. It's the key to the larger question. If our civilization, global and technological, can disappear so completely, what hope would there be of finding the remains of one far older? That realization gives us a benchmark. If anything about us endures, if some aspect of our influence becomes part of the planet itself, that might be the very kind of trace to look for when we ask whether we were the first. Not temples, not tools, but residue transformation chemistry. And some of our most enduring legacies aren't things we've built, but things we've changed. The carbon we've freed into the air, the nitrogen saturating our soils, the isotopes scattered by our weapons, the extinction of species, and the reshaping of ecosystems. These aren't structures, they're planetary edits, difficult to reverse and impossible to hide. Now imagine a scientist millions of years from now extracting a core of ancient sediment. They find a thin, puzzling layer, a spike in carbon, a sudden drop in biodiversity, traces of synthetic compounds, a scattering of isotopes that shouldn't exist. They pause and ask, what happened here? Was it volcanic, asteroidal? Or was there something else, something intelligent behind it? That's the power of this thought experiment. By imagining our own disappearance, we learn what truly lasts, what rises to the level of a geological signal, and what vanishes without a trace. Next, we'll follow that signal, what it looks like, where it leads, and how easily it could be mistaken for something ordinary. Because even if intelligence leaves a mark, the hardest part is recognizing it. Geologists don't speak in years as we do. They speak in layers, in thicknesses of sediment, in isotopes and core samples. Deep time doesn't count in hours or centuries. It moves in events, in patterns far beyond the reach of history or biology. To ask whether another civilization might once have lived and died here, we must first learn to think in that language. Because deep time doesn't tell stories in words, it tells them in stone. Most of what we know about the planet's past doesn't come from fossils, but from the chemistry and structure of its layers. Ocean floors, lake sediments, ice cores, cliffsides, quarries. Each stratum is a page, built grain by grain from dust, ash, and shell. Together they form an archival record of what the Earth was like as those layers settled. It's a fragmented vocabulary, but one we can learn to read. Carbon levels, oxygen isotopes, sulfur ratios, pollen traces, magnetic directions. Each is a word in the planet's long, quiet language. And if we can read it carefully enough, perhaps it will tell us not just the story of life, but of intelligence itself. The rocks tell us many things. They whisper about shifting climates, the breath of ancient atmospheres, the rise and fall of forests, the ebb of entire species. They even remember catastrophe, asteroids striking, volcanoes collapsing, oceans choking on heat and ash. And every now and then, they hint at something stranger. The clearest records come from places where change moves slowly. The deep ocean floor, the still mud of ancient lakes, the frozen layers of polar ice. From these archives, scientists pull slender cylinders of history core and study them millimeter by millimeter. Each band of color, each grain of dust or fleck of fossil, carries a line of the planet's story. A shift in hue might mean a sudden warming. A trace of sulfur might mark a great eruption. Sometimes the clues are subtler still. A minute rise in one isotope, an odd spike in a rare element, a carbon ratio slightly out of tune with the expected baseline. Individually, these signals could be random. Together, especially when confined to a narrow slice of sediment, they suggest something abrupt, something that disturbed the planet's slow rhythm. Our own age, the Anthropocene, is already etching such a signal. Future geologists, if any remain to read it, will see a sharp jump in carbon dioxide, a collapse in biodiversity, residues of synthetic chemistry, and the faint radioactive dust from nuclear tests. A paper-thin line in the crust, standing out against the calm heartbeat of older ages. Not a story in itself, but a disruption, a punctuation mark in Earth's long text. That is exactly the kind of anomaly scientists are trained to notice. So, if another civilization once changed its world in similar ways, even without monuments or bones, we might expect to find comparable scars. But interpreting them is never easy. For every rise in carbon, every trace of an unfamiliar element, nature provides her own explanations. Volcanoes flood the skies with carbon. Asteroids scatter iridium across continents. Microbial blooms leave peculiar chemical residues. The planet has its own language of disaster, and it's easy to misread it when you assume every voice must be natural. Context is everything. A single chemical oddity means little. A pattern of overlapping clues means more. A temperature surge that coincides with mass extinction. A rare compound appearing across the globe, not just in one region. A leap in heavy metals aligned with fossil fuel markers. Only when those pieces fit together do we begin to suspect intention rather than coincidence. And even then, certainty is elusive. The deeper we dig into time, the less clarity we find. The grandest events in geological history, the ancient warmings, the oxygen crises, the mass extinctions, happened hundreds of millions of years ago. Their traces have been stretched, folded, buried, and reborn through the churn of plate tectonics. Stone is strong, but it is not eternal. Layers shift, signals blur, nothing remains untouched. Still, some records refuse to die. Certain isotopes decay so slowly, they serve as clocks for millions of years. Magnetic grains align with the Earth's shifting field, creating a calendar of flips and reversals. Some minerals form only under exact conditions of heat or pressure punctuation marks in deep time that tell us where something unusual once happened. If a civilization ever influenced the planet strongly enough, those subtle markers might be the places its ghost still lingers. But recognition is the hardest part. Even today, scientists stumble across anomalies, chemical spikes, isotope distortions that don't match any known event. Most find natural explanations. Some remain quietly unsolved, tucked into papers and data sets, awaiting a future that might never return to them. They aren't ignored out of apathy, but because science demands patterns, not isolated mysteries. A single data point cannot carry the weight of a civilization. Perhaps that's exactly where an ancient intelligence would hide, misfiled in the geologic record, mistaken for a volcanic pulse or a methane burst, its signature camouflaged by the planet's own noise. To claim otherwise to say, something intelligent did this is an extraordinary statement, one that demands extraordinary proof. That's not skepticism. That's discipline. It's how science protects itself from imagination run wild. But it also means that certain possibilities, however intriguing, remain untouched at the edges of inquiry. The language of deep time is real. It hums through every rock and core sample, through isotopes and sediments. It can tell us what changed, and roughly when, sometimes, even how, but rarely why. That last part lives in the space between data and interpretation, between logic and curiosity. It's there, in that narrow margin, that the question of lost civilizations continues to dwell. Unverified, maybe unverifiable, but not impossible. And so we move forward to the things that endure. Not grand monuments or myths, but the leftovers, the accidental fossils of intelligence. Because if something came before us, it may not have meant to leave a monument. It may have simply lived, and in doing so, changed the earth in ways it could never have foreseen. Some traces vanish almost instantly: paper, cloth, wood. Others linger for centuries: glass, metal, concrete. And then there are the stubborn things, the ones that outlast their makers, not by intention, but by sheer resistance to decay. When we speak of the possible relics of a civilization long erased, that is where we must look, not to what was built, but to what endures. And that list, it turns out, is short. One of the most enduring fingerprints a civilization can leave behind isn't made of stone or steel, it's made of chemistry. Every time we mine a metal, refine a compound, burn a fuel, or alter the air itself, we inscribe invisible lines into the planet's record. These reactions are microscopic, but they reach everywhere. When they happen quickly or across the whole globe, they etch sharp, unmistakable signatures into soil and sediment. Future scientists might not understand the cause, but they'll see the disruption. Something happened here. They'll think and they'll be right. Let's begin with the materials we invent. Modern humanity has produced a library of substances unknown to nature. Plastics, pesticides, industrial solvents, synthetic alloys. Some crumble almost instantly in sunlight or oxygen. Others endure like ghosts. Already, microplastics have been found in deep-sea mud, polar ice, and the thin dust that blankets mountain peaks. Buried and sealed away from air, they could last tens of thousands, perhaps hundreds of thousands of years. Yet even plastic has limits. Exposed to heat and weather, it fragments. Preserved too well, it hides. A layer rich in strange polymers might puzzle whoever comes next. But without context, without anything recognizably artificial that might look like a curious natural deposit, not the remains of industry, metals tell a similar story. We think of them as permanent, but their strength is conditional. Iron rusts, copper turns green, even stainless steel, proud of its name, eventually yields to chemistry. Left alone, a metal tool might survive a few thousand years in dry sand. But over millions? Unlikely, unless it were sealed within rock or locked deep underground. And even then, without obvious shaping or patterning, a relic might be mistaken for raw ore. Radioactive isotopes offer something rarer. Certain elements created only in nuclear reactions simply don't occur naturally in meaningful amounts. Plutonium-234 technetium-99, iodine-129. These could, in theory, outlast empires. If such isotopes ever appeared in the record without any known cosmic or volcanic cause, they would point uncomfortably toward technology. Most, however, decay away within a few million years, fading back into geological silence. Burning carbon leaves another kind of mark. When fossil fuels ignite, they release carbon dioxide depleted in the heavier isotope, carbon-13. That subtle imbalance seeps into sediments and ice. If geologists ever found a sudden, planet-wide drop in carbon-13 relative to carbon-12, they might suspect massive combustion. But nature mimics us well. Volcanoes and methane releases can paint the same signature. Context, again, is everything. Mining and metallurgy leave their own chemical shadows. Heavy metal sleed, cadmium, rare earth, concentrate unnaturally, where humans refine and discard them. High levels clustered in ancient soils, arranged in patterns suggesting processing rather than geology, could whisper of industry. But metals migrate. They leach through groundwater, accumulate in plants, spread through the food web. By the time we find them, their story may already be smeared beyond recognition. What about the physical works themselves, the tunnels, the quarries, the hollowed spaces beneath the surface? Massive excavations might last longer than towers, especially if they alter the local geology. But over tens of millions of years, even caverns collapse, sediment fills the voids, faults shift the land. A mine becomes a cave becomes a memory. Concrete, the quiet cornerstone of modern civilization, is surprisingly alive. Some varieties strengthen with age. As minerals bloom within their pore, sentient Roman harbors still stand in seawater after 2 millennia. Our modern mixes might persist longer, yet even they are vulnerable to moisture, frost, and biology. Given deep time, concrete turns back into rock, its purpose erased. Ceramics and glass fare better. They are chemically stable, stubborn against decay. Shards of pottery survive when everything else perishes, and under the right conditions, they might endure for millions of years. But a shard alone says little. Only when shapes repeat or patterns appear does intelligence announce itself. Beyond objects, there are ecological fingerprints. Agriculture compresses soil, alters erosion, and rewires water chemistry. Fertilizers leave behind nitrogen traces. Pesticides scatter synthetic molecules. Deforestation and monoculture reshape entire biomes, reducing diversity and changing the flow of nutrients. Even long after fields have gone wild again, their scars linger in the soil's layered memory, centuries, maybe millennia, but not deep time. All of this leads to a sobering conclusion. If a civilization once rose before us, its most durable testimony would be subtle. Not statues or machines, but patterns, anomalies that don't quite belong. A blip in carbon, a concentration of metals, a faint disturbance in the patient rhythm of the earth. And finding such signs would demand precision, persistence, and imagination. Because after all these ages, the record we study is older than our own species, and the stories it holds were never meant to be easy to read. The signs that vanish first are the ones closest to us now, the texture of our lives. Books, music, images, all the stories we tell about ourselves. Paper burns, plastic warps, hard drives forget. The great libraries of the digital age would go dark within days of losing power. Cultural memory would fade faster than concrete, languages collapsing, beliefs dissolving, meanings drifting into myth. Within a few generations, even among survivors, once shared truths could become mysteries. And so the question returns: what truly lasts? The answer still is almost nothing. But perhaps, just perhaps, enough. Enough to leave a trace, if not a story. Enough to make someone, someday, stop and wonder, not about who we were, but whether someone once was. Whether the earth, despite all its forgetting, kept a few stubborn signals buried in its slow, silent archive. Now we turn to one of the planet's most powerful erasers, the ocean. If any civilization ever touched the seafloor, the water did not preserve it. It dismantled it molecule by molecule. The ocean doesn't keep records, it edits them. It grinds, dissolves, buries, and drags everything it claims. For a species that live by the coast, this might not have seemed like a threat. The ocean feeds and connects. It moderates climate, carries trade, inspires myth. But when it comes to preservation, especially over millions of years, the ocean is merciless. Anything built beneath or beside it faces erasure. If a civilization ever rose along the shoreline, the odds of us finding its remains today are nearly zero. Even now, our own great cities, New York, Shanghai, Mumbai, cling to the edges of shifting seas. Coastlines change faster than any other landscape. Storms reshape them, tides grind them down, ice melts, seas advance. In geological terms, oceans migrate dramatically. Over the last 20,000 years alone, sea levels have risen by more than 100 meters, drowning entire continental shelves. Vast plains that once held rivers and settlements now lie beneath layers of salt and sediment. Those drowned worlds are almost impossible to reach. Exploring them is not impossible, but it's close submerged beneath tons of mud, hidden under post-glacial deposits that conceal everything. That's why searching for ancient civilizations along those forgotten coasts is so difficult. Not because the idea itself is far-fetched, but because those are precisely the places that have been erased. Underwater archaeology, even in shallow seas, is a slow and fragile art. On submerged continental shelves, buried beneath shifting silt, it becomes an act of faith. Imagine a civilization that mastered the seas-built ports, harbors, ships. What happens to such structures over deep time? Wood decays, rope unravels, stone collapses under its own weight. Metal corrodes almost instantly in salt water. Only if buried swiftly in silt, protected from oxygen, might fragments survive, but even then, not for long. A few thousand years, perhaps, not millions. Even if remnants endured, detecting them would be nearly impossible without precise mapping and high-resolution sonar. Artificial lines, rectangles, right angles, grid scan exist in nature too. Volcanic flows, coral ridges, and current-sculpted sand can form deceptive geometries. Most so-called underwater anomalies, when examined closely, turn out to be natural. Without artifacts or context, certainty evaporates. But let's imagine something larger. What if the civilization didn't just live near the sea, but used it, changed it? Mining, waste disposal, energy production, could those acts leave traces? We know ours have. The modern ocean already bears our fingerprints, vast gyres of drifting plastic, fields of microparticles circling endlessly on currents, mercury and lead poisoning deep-sea fish, isotopes from mid-century nuclear tests, fertilizer runoff spreading hypoxic dead zones along the coasts. Even the deepest trenches, miles beneath the surface, now contain synthetic debris carried down by falling snow and dying plankton. Some of these signals might persist for tens of thousands of years, especially once trapped beneath sediment. If an earlier civilization had similarly altered marine chemistry, introduced synthetic compounds, or shifted nutrient balances on a global scale, we might still find traces today. But they would be faint, and they would need to be distinguished from the planet's own complex patterns, the chemistry of hydrothermal vents, volcanic gases, decaying organic matter. Each leaves its own subtle, confusing imprint That is the essence of what you might call the lost tech test. Could the technological activity of a vanished civilization survive the ocean's editing long enough to be legible? And if it did, would we even recognize it as artificial or dismiss it as just another mystery of geology? Take synthetic molecules. Some modern plastics and industrial compounds resist decomposition astonishingly well. Under cold, oxygen-poor conditions, fragments or residues could endure for hundreds of thousands of years. Buried deep in seabed clays, they might even survive into deep time. But one fragment means nothing. Only global distribution would hint at civilization. And mapping such patterns requires oceans of data, something marine science is only beginning to achieve. Heavy metals and rare earth elements tell a similar story. Used in electronics and industry, they gather where humans refine or discard them. Unusual spikes in these elements within ancient sediment layers could point to processing or pollution. But volcanism and hydrothermal activity can create the same enrichments. To separate the natural from the technological, you'd need context, ratios, isotopic patterns, and a precise understanding of background conditions. Even deep-sea mining would blur into ambiguity. After enough time, even the most deliberate excavation could become indistinguishable from nature's restless geology. On the ocean floor, everything eventually moves. Modern industry is already reaching into the deep. Mining companies have begun eyeing the ocean floor for its hidden riches, manganese nodules, cobalt crusts, rare metals scattered across the abyss. If something like this had ever happened before, its ghosts would be subtle. A patch of sediment missing its expected minerals, layers disturbed or chemically inverted. But how do you detect an absence? And even more difficult, how do you prove that what's missing was taken by intelligent hands? Energy use offers another path. Every civilization that reaches a certain level of complexity must find a way to feed its engines. That hunger leaves residue waste heat, altered chemistry, and byproducts written into air, water, and soil. In humans, it takes the form of carbon dioxide, industrial gases, rising temperatures in rivers and seas, and plumes of thermal pollution spreading like invisible ink through the oceans. If a previous civilization had drawn power from sources that left behind durable traces, radioactive isotopes, synthetic compounds, or chemically unique byproducts, those might still whisper from the sediments. But they'd have to be everywhere, large enough to stand apart from natural background noise, and that's the problem. Even if those traces exist, they don't announce themselves as civilization. They appear as chemistry, as anomalies, as tiny irregularities in a dataset already full of variation. Without geometry, repetition, or something unmistakably artificial, tools, structures, patterns, they remain unexplained. Just more static in the planet's long, slow signal. That's why the lost tech test isn't about whether a civilization had machines. It's about whether those machines and their wastes could survive the grind of deep time, and whether, if someone found them, they'd even recognize what they were seeing. So let's surface again, not to search for what's gone, but to listen for what remains. Because while the ocean erases, the land sometimes remembers, and memory, in its strangest forms, can outlast matter. Not in steel or stone, but in stories, in myths, in echoes. When people speak of cities swallowed by the sea, they reach for familiar names: Atlantis, Lemuria, Aegeans carried through centuries, reshaped by imagination. But the real ocean has consumed real cities, and none have left monuments behind. The sea is not a museum. It's an editor. It dismantles carefully, but completely. When a city falls beneath the waves, what survives after a few thousand years, let alone a few million, is not marble columns or tiled floors. It's silence. Civilizations have always been drawn to coastlines. Fertile land, easy trade, stable weather, these are the foundations of complexity. But to build by the sea is to build on the edge of change. Coastlines aren't fixed boundaries, they breathe. They shift with tides, storms, earthquakes, and glacial rhythms. What's land today might have been seabed 50,000 years ago, and what's seabed now might once have been home. Take Dwarka off the coast of India, a place some describe as one of the world's oldest underwater urban sites. Its blocks and walls appear deliberate, yet erosion, coral growth, and time have blurred their origins. Pavlopetri off Greece tells a similar story, a ghost grid of streets beneath the Aegean, fragile but human-made. And then there's Doggerland, the sunken plain beneath the North Sea that once linked Britain to Europe, now buried under silt and tide. These are not myths. They're memory, made visible recent, shallow, barely preserved. But go back further, and the ocean stops keeping even that much. The sea floor is never still. Currents stir the sediments, reshaping the land. Marine creatures colonize and digest whatever remains. Corrosion eats at everything exposed, and new layers are always forming, burying and blending what came before. That's why submerged ruins never look like ruins for long. Even stone yields to the patient abrasion of salt, pressure, and biology. Corners round off, carvings fade, mortar dissolves, organic traces vanish. A fallen wall becomes an underwater ridge. A temple collapses into the geometry of a reef. Given enough time, everything that once seemed deliberate merges into the natural. And that's for cities only a few thousand years gone. Stretch that span to 10 million, and imagination falters. Even a civilization of towers and steel, far beyond our own, would leave no skyline beneath the sea. The ocean would have digested it, turned it over, and scattered it until all meaning dissolved. Then there's the matter of accessibility. Most of the ocean floor remains unmapped. We've charted the surface of the moon in finer detail than the deep earth beneath our seas. Even where we have maps, the resolution is coarse good enough to spot a mountain, not a monument. Sonar, submersibles, and core samples offer glimpses, but they're slow, expensive, and blind to all but the most obvious features. If something small or buried lies waiting, we might never see it. Some researchers look instead to ocean sediment coruscants, cylinders of ancient mud that act as time machines. Each layer captures the chemistry of the sea, the dust of continents, the breath of volcanoes. These cores reveal past temperatures, salinity, plankton blooms, even asteroid strikes. And sometimes they show anomalies, A carbon spike here, a metal-rich band there, a layer of odd isotopes that doesn't fit the usual rhythm. None have yet been linked to civilization. But that doesn't mean the signals aren't there. It might mean we haven't yet learned how to listen. If a civilization once built along ancient shore, as if it spilled waste into the sea, altered ecosystems, or rewrote ocean chemistry, its fingerprints might still linger in the deep. But to see them, they'd have to be vast, global, unmistakable. Even then, the story they tell would be fractured, incomplete, difficult to decipher, because the ocean doesn't preserve, it edits. And what it keeps without context. Think of Fukushima, 2011. Within days of the reactors failing, radioactive isotopes spilled into the Pacific. Within months, they were measurable halfway across the world, drifting toward North America. It was a tragedy recorded in real-time data, isotopic fingerprints, all neatly documented. Now imagine trying to detect something like that 50 million years from now. No records, no context, no surviving technology, just a faint chemical echo in the rock. Even if traces of those isotopes somehow endured, their origin would be pure speculation. Because the ocean isn't a vault. It's a processor. It stirs, digests, and reuses everything it touches. Water, nutrients, sediments. They cycle endlessly through physical and biological systems. The sea chews up evidence and feeds it back into the planet's circulation. Cities don't sink and stay there, preserved like Atlantean relics. They dissolve. They blend. And unless we catch them in the act of vanishing, they become part of the sea's deep memory, a memory written not in ruins or maps, but in gradients of chemistry and contour. So if a city falls into the sea and no one remembers it, was it ever truly there? From a geological standpoint, probably not, at least not in a way anyone could ever prove. Yet those drowned landscapes still matter, not as proof, but as parable. They remind us how swiftly complexity collapses, how fragile presence is even when carved in stone. These are not the ruins of forgotten empires from 100 million years ago. They are warnings, soft, shifting previews of impermanence. Reminders that forever is a human invention and that nature does not recognize it. Now we leave the water behind. From sea to stone, from things devoured by tide to things sealed in rock, because while the ocean consumes, geology sometimes remembers, and every so often the earth seems to keep something it shouldn't. Not a monument or inscription, but a mystery, a thing out of place, something that doesn't belong. And the closer we look, the more it seems to whisper that history might not be finished telling its story. When scientists read the layers of stone, they're searching for rhythm and reason. Was the world hot or cold? Were the oceans wide or shallow? What forms of life filled the air or swam the depths? Each layer is a line in a planetary diary, written in minerals and dust. But sometimes there's a line that doesn't fit, a sentence out of order. These are anomalies. And while most eventually earn an explanation, a few still sit quietly in the margins, waiting for new tools or new imaginations to make sense of them. Not every anomaly is mysterious. Geology abounds with strange but natural shapes. Twisted veins of mineral, misplaced fossils, odd layering born from storms, or volcanic ash. But once in a while, something turns up that feels too deliberate, too regular. A pattern that seems designed. A fragment that looks as if it were made, not formed. Take the old stories of artifacts in coal, reports from the 9th and early 20th centuries, where miners claimed to find metal objects sealed inside lumps of ancient carbon. Chains, bells, carved stones. Almost none were verified, and few samples survived. Coal seams fracture easily. Debris from modern times can fall in and be mistaken for something ancient. Confirmation bias likely did the rest. The claims proved nothing, but they revealed what people expect ancient technology to look like and what they most want to find. Then there are the South African spheres, metallic marbles found in Precambrian rock more than 2 billion years old. Some had grooves that seemed machined. For decades, they circulated through tabloids as proof of impossible antiquity. Yet closer studies showed they were natural concretions, iron and pyrite shaped by pressure and time. The grooves weren't writing, they were weathering. Beautiful curiosities, yes, but not artifacts. Most anomalies end up that way, explained, reclassified, or simply forgotten. Science by nature is careful. It doesn't leap toward the extraordinary when the ordinary will do. A claim that challenges everything demands evidence that withstands everything. That's why a strange object in stone is always interrogated the same way. Could this have formed naturally? Was the layer disturbed? Could there be contamination? Has it been independently verified? If those questions can't all be answered, the find remains in limbo, interesting, but unresolved. And not all anomalies are objects, some are chemical. Sometimes a rock layer suddenly shifts its isotopic ratios, the balance of carbon, oxygen, sulfur. These events are called isotope excursions, and they're visible as thin streaks of change in the record. Most have known causes: vast volcanic outbursts, methane releases, asteroid impacts. But not all of them are fully understood. A few show rapid warming, ocean acidification, and mass extinction compressed into a geological heartbeat. To some scientists, they echo what's happening now or own Anthropocene's signal unfolding in real time. And so the quiet question arises. If a layer like that existed deep in the past, with the same chemical patterns as ours, would we recognize it as a signature of intelligence? Almost certainly not, because intelligence isn't required to explain catastrophe. Nature makes chaos on its own. But imagine, for a moment, that one of those ancient layers showed everything: synthetic molecules, industrial isotopes, rare metals scattered across continents, and no volcano or asteroid could account for it. That would be harder to ignore. Yet we haven't found such a layer. Or if we have, it's sitting in a database somewhere labeled simply unusual, waiting for a question no one has thought to ask. It's worth remembering. Many of science's greatest discoveries began that way. Not by finding what was expected, but by noticing what didn't fit and refusing to look away. Plate tectonics was once a fringe idea. So was the asteroid that ended the dinosaurs. Reality, it turns out, often hides in the anomalies. The data had been there for decades: numbers, charts, chemical ratios, but no one saw the pattern until someone finally connected the dots. That's how discovery works. An anomaly means nothing until someone asks why it's there. It becomes meaningful only when context turns noise into signal. And that's where the idea of lost civilizations returns. If any traces exist, they might not be grand. They wouldn't look like monuments or machinery. They'd appear as subtle deviations, an unusual mineral deposit, a strange spread of metals, a synthetic molecule fossilized in ancient stone. Each one alone could be explained away, but taken together, they might whisper of something more deliberate. It's even possible we've already found them quietly, unknowingly. A geological pattern attributed to natural weathering. A layered structure dismissed as a sedimentary oddity. A chemical spike explained by a methane bloom. And most of the time, those explanations are probably right. But what if, in rare cases, they aren't? We don't know how an ancient civilization would appear in the rock record. We don't know what kind of chemistry or geometry it would leave behind. But we do know what does endure. Anomalies, residues, imbalances that survive the churn of deep time. If any signal remains, however faint, that's where it would live, buried in the patterns we've already measured but not yet understood. So we keep looking. Not for cities or statues, but for coherence hidden in chaos. Not for messages in words, but for messages in data messages that weren't left intentionally, but are still there, waiting to be read. And that brings us to another kind of record. When geology runs out of layers and archaeology runs out of artifacts, all that's left are stories. Not measurements or maps, but myths. Because sometimes history doesn't vanish, it echoes, and the boundary between memory and imagination is thinner than we like to believe. Myths are not data, but they are persistence. They travel further than monuments. They outlast empires. They survive even when languages die. And while few take them as literal history, more and more researchers are realizing that myths can hold kernels of truth, distorted, reinterpreted, but not entirely imagined. This idea is not new. Every culture carries its own deep time memory. Tales of floods, of fire, of stars falling from the sky, of lands that once existed and then were gone. They speak of golden ages cut short, of vanished knowledge, of islands swallowed by the sea. Individually, they read like poetry or metaphor. Together they form a chorus shara, shared anxieties, shared experiences, perhaps even shared memories of real events that happened before writing began. Among these stories, one theme rises above all others: the flood. It appears in Sumerian tablets, in Babylonian epics, in Greek and Hindu traditions, in Norse legends, and in the Bible. The details differ, but the essence is the same. A vast deluge ends a previous world, sometimes as punishment, sometimes as renewal. A handful of survivors remain, warned in dreams, climbing mountains or building vessels to endure the water's rise. It's tempting to treat all this as allegory, a reflection of human fear, or a metaphor for rebirth. But the geological record tells a parallel story. At the end of the last ice age, glaciers melted and sea levels rose by more than 100 meters. Coastlines shifted, lowlands drowned, rivers became estuaries. For the people who lived then, entire worlds disappeared beneath the horizon. It isn't difficult to imagine their descendants turning that loss into story, into the memory of a flood that washed away an age. Other myths speak of lost lands, Atlantis, Mu, Kumari Kundam, High Brasil. Places described as radiant, powerful, doomed. Their fates differ: hubris, war, divine wrath. But the endings never do. The sea comes. The land sinks. The people vanish. Only the legend remains. Modern scholarship treats these as allegory, political fiction, or proto-national myth-making, and often rightly so. But even fiction can preserve echoes. The memory of a submerged land can outlive the land itself. And there are other recurring motifs, stories of lost knowledge. Tales that speak of an earlier time when people knew more than they do now. When the stars were understood, when the earth was ordered, when wisdom was commonplace. Then something changed. Something was forgotten. The light went out. These are not proofs, they are questions. How do entire cultures come to believe they once possessed understanding now lost? Why do so many describe a fall not of morality, but of memory? And within those stories, there are anomalies to phrases that don't belong to their era, descriptions of phenomena that shouldn't have been known, hints that the past may have been less simple than we imagine. Not all of these strange reports come from fraud or fantasy. Many were made by people who meant well observers, who lacked the instruments or language to interpret what they had found. Others were simply mistakes. The mind's pattern-making instinct mistaking the random for the deliberate. A ridge that looked like a wall. A vein of ore that seemed carved. A coincidence dressed as intention. And yet, the impulse behind these stories, the belief that something came before us, isn't misguided. What's flawed is usually the evidence, not the desire. The motivation makes sense. We want to belong to a longer story. We want to know that the arc of intelligence didn't begin and end with us. Because intelligence is not a miracle. It's an emergent property of complexity, and over billions of years, it's reasonable to ask whether it might have arisen more than once. Science demands rigor, yes, replication, data. But it also depends on questions. And the best questions often start with what doesn't fit with the outliers that force us to look twice. Most anomalies fade into nothing. A few, however, open entirely new fields of inquiry. So even if the tektites are nothing more than splash-formed glass, even if the ancient tools belong to species we already know, and even if the tall tales dissolve under scrutiny, they still have a role to play. They remind us to stay curious, to wonder what we've missed, to accept that the boundary between natural and artificial, between coincidence and pattern, is not always clear. And that's where we go next, deeper into that uncertainty. Because not every civilization would have followed our path. Not every intelligence would have chosen stone or metal as its medium. And if some never did, their remains, if they exist, might already be beneath our feet, invisible, unmarked, but not entirely gone. When we imagine civilization, we picture familiar things: tools, buildings, machines, writing, monuments. Almost all are made of, or shaped by, metal. Our entire concept of progress is welded to it: the Stone Age, the Bronze Age, the Iron Age, a ladder of elements. But that framework assumes a single model of development. It forgets that metal isn't required for complexity. It's just what we happen to use. So what if another civilization never reached for it? What if it evolved, thrived, and vanished without ever smelting ore or forging alloy. It isn't far-fetched. For most of our own species' history, we lived entirely without metal. Early humans crafted tools from diamond, wood, and bone. They built shelters, tamed fire, wove fibers, painted walls, told stories. They understood animals, mapped the stars, made clothing and art all before touching a single vein of copper. Even now, many indigenous cultures maintain complex societies with little or no metallurgy. Complexity doesn't begin with metal. Metal simply makes complexity visible to archaeologists. So if a pre-human or non-human civilization had flourished without it, what would their record look like? The answer is simple and unsettling. It would be almost impossible to find. Organic material fades quickly. Wood, fiber, hide, and bone all succumb to decay unless entombed in ice, salt, or desert. Textiles rot. Wood burns or crumbles. Moisture, heat, and biology erase design. Without metal, stone, or ceramic to carry memory forward, nothing lasts. Even when preserved, organic tools are often overlooked. A bundle of fibers might be a root system, or it might be string. A hollowed trunk might be a fallen log or a canoe. Without context, the distinction collapses. Now imagine a civilization that built everything from life itself. Houses of woven reeds, tools of hardened wood, vessels of leather or gourd, pigments drawn from ash and soil, writing brushed in smoke or sand. No mining, no smelting, nothing left to rust or fossilize. Such a culture could thrive for thousands of years and still vanish without a geological trace. A forest could reclaim it in a decade. Erosion could take the rest. And after 1,000,000 years, not even a whisper would remain. Even fire, that ancient hallmark of intelligence, leaves a faint signature. Charcoal layers, ash beds, stones fractured by heat. But lightning, volcanoes, and wildfires make the same marks. To tell the difference, you need context: hearths, patterns, residues, artifacts. Without those, a campfire becomes indistinguishable from a storm. Some tools might endure, especially stone. But not every stone tool looks like one. Natural fractures can mimic flaking. Erosion can shape edges that seem deliberate. Only when repetition emerges, angles repeated, wear marks consistent, geometry intentional, does pattern become proof. And so, if intelligence once walked the earth before us, its record might lie not in monuments or metal, but in patterns we've already mistaken for chance. A pebble used to grind grain or soften fiber might never bear a mark. A sharp stone used to cut might never be reshaped. If tools aren't kept, curated, or passed down, they dissolve into the background noise of nature. And if they're used in ways that leave no wear, no polish, no pattern, then after the users are gone, they are simply stones again. It's even possible for a civilization to reach astonishing understanding, astronomy, agriculture, medicine, without ever building furnaces or cities. Knowledge doesn't always need industry to thrive. A society could map the stars with the naked eye, chart the seasons with wooden posts or standing stones, breed crops by patient observation, mark time with water and shadow, compute with knots or beads, and pass entire cosmologies through encoded song. None of that demands metal-only memory. And memory is the most fragile technology of all. When continuity breaks, Through disaster, disease, or migration, the knowledge can vanish faster than the tools decay. Language, especially, is mortal. Spoken words die with the speaker. If they are not carved or recorded, they disappear completely. Even written records, if made on bark, leaf, or cloth, fade and rot. Inscriptions in pigment or sand vanish in days. Unless something is intentionally preserved, time claims it. So a civilization that never needed a durable scripter, never invented one, could live and die unrecorded. All that brilliance, all that structure, absorbed back into the silence of the earth. Then comes the question of scale. Not every civilization builds monuments. Some remain nomadic. Some dissolve into their ecosystems. Some value impermanence. Our definition of advanced is biased toward what leaves a scar: architecture, pollution, energy use. But those are cultural choices, not evolutionary laws. A society could be technologically adept, even philosophically evolved, and still choose to leave almost no footprint, especially if experience had already taught it that heavy footprints lead to collapse. If such a people existed, what would remain? Perhaps terraced hillsides, altered river courses, unfamiliar species growing where they shouldn't, traces of controlled fire, enriched soils, managed forests, signs of design, mistaken for chance. We already have examples of this subtle legacy in our own age. In the Amazon, there is a soil called terra preta, fertile earth enriched by ancient hands. It contains charcoal, bone, pottery shards, and organic matter arranged in ways that suggest deliberate engineering. For centuries, it was dismissed as a quirk of geology. Only recently have we begun to understand it as a technology, a living soil created by people who shape the rainforest itself. It doesn't look like a city. It looks like dirt. Yet it carries the memory of a complex, sustainable civilization that changed the world not through conquest, but through cultivation. If something like that had happened 100 million years ago, with fewer pots, fewer stones, and structures built entirely of living material, we might never know. Especially if it lay in a region now drowned, eroded, or subducted beneath the crust. Civilizations without metal may not have vanished because they failed. They may have vanished because they succeeded in living gently, in blending with their world, in valuing renewal over permanence. And from the planet's point of view, that success would look like silence. We tend to define progress by what it leaves behind, but absence is not always failure. Sometimes it's choice, sometimes it's wisdom, and sometimes it's simply time keeping its promise that nothing made of breath and clay was ever meant to last forever. Next, we arrive at that silence, the quiet aftermath of all that living and forgetting. Not just the physical gaps in the record, but the deeper uncertainty that follows when the ground stops speaking. Soil holds memory, but not loudly. It remembers what grew, what burned, what bled, what passed through. It records footsteps, absorbs rain, ash, decay. But it never shouts its history. It whispers it in fragments, in stains, in chemistry. Dig deep enough, and you might find a trace. A hearth turned to charcoal, a patch of darkened earth where a wall once stood, a pattern of nutrients marking where crops were grown. But more often, you find only silence. And in that silence, we begin to see how fragile a record civilization truly is. We think of soil as surface, but it's really an interface, a membrane between the living and the non-living. Every falling leaf, every dying organism, every root that burrows through it leaves a faint signature, shaping the layer beneath. Over time, those layers compress, fade, harden into sediment, and sometimes, if they're lucky, stone. Most are not so lucky. Most are turned over, eroded, or washed away before they can speak. What survives is rare. And even when it does, it doesn't always tell us who. Only that something was once alive, that something once moved through here. Discoloration, disturbed layers, traces of chemistry altered by decay, by offerings, by the ordinary presence of life and death. But these signs are fragile. A few centuries of rain, a few seasons of plowing, and the record blurs. In geological time, it vanishes altogether. Only under exceptional conditions, sealed in ice, trapped in desert salt, or locked within a peat bog, does soil preserve what it once held. Everywhere else it breathes and forgets. This is why the civilizations we know are traced through stone and metal, not through earth. The information written in dirt doesn't last without context. And when context is stripped away, when artifacts, architecture, and stratigraphy fall out of alignment, soil stops telling a story. It becomes static. It becomes noise. Or it becomes nothing. Still, silence has begun to yield to patience. New disciplines read the ground differently. Archaeobotany studies the ghosts of plants, pollen grains, phytoliths, seeds to rebuild ancient landscapes. Geoarchaeology looks at chemistry, texture, and layering, inferring presence from faint patterns. Blackened soil that might be fire. Phosphate-rich patches that might mean habitation or waste. Unusually fertile bands that might whisper of long-term farming. But every clue requires interpretation. High phosphate might mean livestock, not people. Dark soil could be a hearth or just a lightning scar. Char-enriched ground might be a managed garden or the residue of a forest fire. Without pattern, without repetition, these signals never rise above the background hum of nature's own experiments. And so, when we ask whether another civilization might have lived in the deep past, we face a hard truth. Soil will not confirm it. Not alone, not after millions of years. Even if they plowed fields, raised dwellings, reshaped rivers, their traces would be absorbed, compacted, turned over, erased. The land forgets, completely. It's a sobering idea that a culture could exist, build, sing, believe, and disappear so fully that even the ground it stood on no longer remembers. Not from cruelty, just from indifference. Time is not a destroyer. It's an editor. It keeps what resists and rewrites the rest. And soil, by nature, does not resist. It cooperates. It recycles. It joins the flow. Even if a few residues remained, how would we know? What separates an ancient garden from a meadow reclaimed by wind? A fire pit from the ashes of a storm? A footpath from a game trail? As centuries pass, those distinctions blur. At some point, action and accident merge into one texture. And what survives is rarely what mattered most. Stories do not fossilize. Relationships leave no isotope signature. Rituals, laughter, pain, they do not show up in a soil core. Even objects lose meaning when their context is gone. We've uncovered tools whose purpose we can't guess, languages we can't read, symbols no one can decode. And those belong to civilizations we already know existed. The silence left by an unknown one would be deeper still. So, when we sift through the earth for evidence, we must decide what we're willing to recognize as significant. A chemical spike, a dark band of char, a patch of unusually rich soil. Are these signs of intelligence or just noise? The line between the two is thin, and in deep time, it almost disappears. But even that silence speaks. It tells us that intelligence can rise and fade without trace, that the earth does not distinguish between life that acted through instinct and life that acted through thought, that everything not made to endure will be reabsorbed, and that without something durable, strange, unmistakably artificial, everything eventually becomes just another shade of soil. So we turn now from silence to speculation, not about what we might find of them, but what they might find of us. Because imagining our own disappearance gives us the clearest mirror into what traces a lost civilization might leave behind, and what it might take to notice them at all. If humanity vanished tomorrow, the world would notice it first. Cities gone still, lights flickering out, airliners motionless on runways, roads empty beneath their rain. For a few short years, the planet would hold its breath. Then the silence would deepen. Power plants would shut down, water systems would fail, vines would climb glass towers, and roots would split concrete. The human absence would echo for a moment, and then dissolve into the rhythm of the biosphere. But in geological time, that moment would pass in the blink of an eye. Our absence would leave almost no scar, except for a few strange signals in the record we are still writing. Because even now, the fingerprints of our era are being pressed into stone. The chemistry of the atmosphere is shifting. Carbon dioxide has spiked to levels unseen in millions of years. Methane concentrations rise. Nitrogen cycles, once stable, are rewritten by fertilizer. These changes are global, synchronous, and abrupt. Future geologists, whoever they are, will see them clearly. Even without knowing the cause, they will see the event, and they will see the layer that bears our name. Plastics, synthetic polymers, and industrial residues are already forming a geological stratum of their own. From landfills to ocean floors, they are being woven into sediment mingled with pollen and plankton, settling into the crust of tomorrow. Microplastics appear in mountain snow, in deep sea cores in our own blood. They are breaking down, but not gone, dispersing, but not erasing. 1,000,000 years from now, they may still glimmer faintly in the rock, a thin, artificial horizon stretching around the globe, a layer the earth never made by itself. We're also changing the planet's minerals quietly, chemically, irreversibly. Industrial processes are birthing new species of stone. Fly ash from coal, slag from smelting, shards of concrete, synthetic pigments, and artificial alloys. Each is a techno-fossil in waiting. They form now in landfills and foundations, pressed into the crust, with us still walking above them. One day, they'll appear in the rock record as sharp-edged inclusions, precise elemental ratios never found in nature, our fingerprints crystallized. And then there's the radiation. In the mid-20th century, our species dusted the entire planet with isotopes, cesium 137, plutonium 239, strontium 90. Traces of these still rest in the bones of whales and in the polar ice. They decay, yes, but slowly, predictably. Tens of thousands of years from now, a thin radioactive band will still thread the Earth, a brief flare in the geological heartbeat of the planet. To any future observer, it would look like a sudden pulse of energy, a burst with no volcanic or cosmic cause. A single line that says, something powerful happened here. Our cities, by contrast, won't last long enough to speak. Steel rusts, glass shatters, concrete fractures from within. Roots pry open the seams, water invades the rebar, and the weight of time pulls everything down. Within decades, the skyline will sag. Within centuries, the forest will reclaim it. In 1,000 years, you'd have to dig to find the bones of a metropolis. In 10,000, even those bones would crumble. Only the unlucky ones, buried by flood or ash, might fossilize, sealed in place like Pompeii under a deeper sky. But meaning, the architecture of intent, will already be gone. Deep underground, a few structures might persist. Subway tunnels, waste vaults, bunkers carved into stable bedrock. Perhaps, one day, explorers will find smooth corridors lined with strange minerals and mistake them for natural caves. A data center might resemble a geode, a missile silo, a volcanic throat. Our machines won't fare better. Metals corrode, plastics crack, wiring disintegrates. Buried engines might survive in part, iron ghosts caught mid-motion, circuit boards turn to mineral mosaics, but function dies first, and form soon follows. Technology was built to work, not endure. Our data, the sum of our thought, is the most fragile of all. Magnetic drives fade. Optical disks cloud. Solid-state memory loses its charge. Unless engraved in stone or metal, our archive will evaporate. The written word, the photograph, the simulation, all will vanish like breath on glass. In the rock record, our digital age might appear as nothing more than a chemical murmura layer, rich in carbon and polymer dust, marking a time when something alive tried to remember itself. Agriculture may linger longer. Our reshaping of landscape, stir-raced hills, monoculture fields, has altered erosion, soil chemistry, even evolution. Fossilized pollen could tell of sudden dominance. A handful of species where once there were thousands. Future botanists might trace the echo of our farming in the thin chemical scars of fertilizer and fire. A story of abundance and collapse, of cultivation without continuity. Our animals, too, will speak for us. Dogs, cattle, sheep, pigs, their bones genetically distinct, clustered around the ghost footprints of our cities. Maybe a fossilized coral reef laced with antibiotic residues, a record of how one species fed another to exhaustion. Fossil fuels will leave their own signature. The combustion of ancient life, burned in a geological instant, will show up as a carbon spike compressed into a few centimeters of stone. It will mark an imbalance. A sudden fever in the planet's long, steady pulse. A signal so abrupt and global that even without context, it will stand out as an event. So, what remains of us? Not our monuments, not our stories, but chemistry ratios of carbon and nitrogen, unusual isotopes, synthetic molecules, A dip in biodiversity, a strange new mineral stratum, a line in the rock, sharp enough, fast enough, global enough to whisper that something intelligent once walked here, something that built and burned and buried itself inside its own signal. And to whoever comes after, if anyone ever does, that might be enough. Not enough to know who we were, but enough to know we were. And maybe to wonder what happened. Next, we turn the question over. If something came before us not thousands, but tens of millions of years ago, where is their line? If the silence of the past isn't proof of absence, but proof of erasure, then what would it take to leave no mark at all? And how likely is it that someone already has? Because the Earth is not an archive. It's an organism, a live, moving, self-healing. Plate tectonics grinds old crust into magma. Erosion scatters mountains into sand. Forests rise and burn. Rivers redraw continents. Even without catastrophe, the planet itself is enough to erase almost everything that ever touched it. But the vanishing of stone and metal isn't the only mystery. There's also the absence of story. No myth that clearly remembers them, no lineage that descends from them, no genetic fingerprints pointing back to artificial origin, no interruption in the evolutionary chain, no cultural echo, just silence. Perhaps the answer is scale. Our civilization is barely an eye blink. Agriculture, 12,000 years. Industry, 200. Digitalist than a lifetime. And yet, we've rewritten the planet's chemistry. Now imagine another civilization, equally brief, that rose 50 million years ago. What would remain? A few thin layers, a handful of anomalies, a faint signal, long since blended into the natural background. We often assume intelligence accumulates, that it climbs, learns, and endures. But that's our arrogance speaking. Evolution doesn't promise continuity. A species can vanish in a generation. A culture can end in a season. Complexity is not a shield. Perhaps they ended suddenly. A war, a warming, a technology too clever for its own survival. Or perhaps they ended slowly. Soil exhausted, oceans emptied, systems too vast to adapt. Not with an explosion, but with a quiet, irreversible fade. If they collapsed, their numbers might have fallen fast, scattered, diminished, forgotten. With no one left to remember, memory itself would dissolve. Language would fray. Stories would fade into noise. Knowledge would turn to dust. Or perhaps they didn't fall at all. Perhaps they turned inward, not to space, but to stillness. Maybe they saw the limits of expansion and chose to stop building upward, to live lightly, to blend back into the world that birthed them. A quiet ending, deliberate and graceful. Not a fall, but a release. If so, they might have erased themselves so completely would never know they were here. There's also the unsettling possibility that they never lived long enough to leave a story, that intelligence flared briefly, a spark that never caught, a mind that awakened only to vanish snuffed out by predators, disease, or the simple indifference of chance. Not every spark becomes fire. And in a world of hazards, a species might achieve consciousness without ever building culture. Culture without civilization. Civilization without resilience. And if we ask where they went, we also have to ask who we imagine them to be. Were they like us? Bipedal, tool-using, language-shaping? Or something stranger, octopus minds of the abyss, arboreal networks of thought, oceanic collectives whispering in chemical codes? Intelligence doesn't have to look like us. It doesn't have to build machines or carve its story in stone. It only has to wonder. And if it ever did, we might not know how to recognize it. Perhaps we've been asking the wrong version of the question. Not where did they go, but what were they to begin with? If they existed, recognizing them would demand that we look beyond ruins and relics to absences, to disruptions, to patterns that resist natural explanation, yet don't shout machine. Not temples in the dust, but irregularities in genes, sediments, isotopes, small, persistent fingerprints that don't match the planet's rhythm. Maybe they never went anywhere. Maybe they were absorbed, recycled into dust and code and cell. Maybe we've already dug through their cities without knowing, mined their monuments into raw material, reforged their foundations into silicon. Perhaps their legacy isn't gone, just scrambled, diluted, repurposed by Earth's relentless metabolism. Or maybe they are still here. Not as beings, but as systems, ecosystems they altered, rivers they redirected, genomes they edited so deeply we now call the results natural. Structures too old to be claimed, too strange to be remembered, too changed to be recognized. Remnants that no longer announce themselves because they no longer know us as their audience. The deeper we dig, the more we see that loss isn't always violent. Endings don't always come with warning. On a planet like this, disappearance can be absolute quiet, clean, complete. Next comes the harder question. Not whether they existed, but whether we would believe it if we found them. Because knowledge isn't just about data, it's about recognition and belief. Rewriting the story of who came before us has always been the hardest act of science. Not because the evidence is missing, but because humility is hard. Science doesn't demand humility, the universe does. Every time we've imagined ourselves at the center, we've been moved outward, first from the earth, then from the sun, then from any special place at all. And now, when we turn our gaze inward into the deep past of our own planet and ask if we were the first to awaken, we face a final decentralization, not of position, but of time. It doesn't say we weren't first. It simply reminds us we might never know. That's the humbling possibility, that intelligence is not unique, that it can rise more than once on the same world, and that it can vanish so completely the world forgets it ever was. Not because it left no traces, but because we've already explained those traces away. We never saw them for what they were. We assume that if something mattered, it would be obvious. But permanence is the exception, not the rule. Even within our own 10,000 years of history, most of what was built is gone. Whole cultures vanished without record. Whole cities left no ruins. If that much can disappear in a heartbeat, what could vanish across 10 million years? Or 100? The geological record is not a book. It's a jigsaw missing almost all its pieces, and the box has no picture. We only notice the pieces that contrast the black against the white, the jagged against the smooth. The strange things catch our eye. The subtle ones fade into background. That's why the idea of a pre-human civilization isn't absurd, it's difficult. It exists in the one region where evidence is weakest and interpretation is softest. It asks science to make room for doubt without surrendering to fantasy. Most scientists don't reject the idea out of pride. They do it out of discipline. Extraordinary claims need extraordinary proof, and so far, there is none. No machine in Permian rock, no coded message in carbon layers, no pattern that demands an architect. And yet, absence of evidence is not evidence of absence. Sometimes the scale of time itself is the silence. Not because nothing happened, but because the earth is good at forgetting. That's where humility returns, not as defeat, but as honesty. We don't know if we're the first. We may never know. And if we're not, we may never find the proof. And if we do find it, we may not recognize it for what it is. Even now, as we map anomalies, as we trace extinction layers and chemical shifts, we're guided by our own expectations, by what we already know how to see. A buried city? We'd understand that. A spike in iridium or carbon? Probably a meteor. A global pulse of warmth or ash? Volcano, fire, flood. But to see something unprecedented requires imagination trained in humility. That's not just a scientific limit, it's an emotional one. Because if we admit that something like us came before us and disappeared, then progress is not destiny. Civilization is not security. Intelligence is not permanence. It becomes a fragile chance. A candle in deep time, a thing that may come and go and come again or not. And then comes the final question. If there was someone before us, someone who dreamed, built, and vanished, what does that mean for us now? Does it make us less unique or more connected? Are we their continuation or their echo? Their redemption or their repetition? We don't know. And maybe that's the point, because in the silence between what we know and what we imagine, the earth keeps its secrets, and we, for the moment, are one of them. It's possible that the most lasting legacy of any prior civilization isn't material at all. It's conceptual. It's the idea that they could have existed, that we might not be the first, and that someday someone might ask the same question about us. What will they see when they look back? A spike of carbon, a scattering of plastic, a brief shimmer in the sediment. Will they call it a civilization? Will they call it a tragedy? Will they call it proof that they are not alone? We imagine the past as something fixed, but it isn't. It shifts each time we look at it with new tools, new light, new questions. And this question, the one about lost civilizations, isn't really about the past at all. It's about how much of the unknown we're willing to live with, how much wonder we allow back into our model of the world. Not every mystery demands a solution. Some just want to be acknowledged. And this one, maybe more than any other, asks not for belief, but for attention. Soon, this journey will close. Not with an answer, but with a pause. Because for all we've asked, all we've imagined, the night still holds more than we can grasp. And maybe that's enough. So, here we are, at the quiet edge of the question. After all the digging, all the wandering, all the long walks through stone and silence, what remains is stillness. And in that stillness, something gentle happens. The question softens, not because it's answered, but because it's been heard. Maybe we are the first. Maybe we're not. Maybe intelligence is rare. Or maybe it's shy, blooming in hidden corners, fading before it leaves a mark. Maybe the earth has carried more minds than we'll ever know, each flickering into awareness, shaping its moment, then slipping quietly beneath the next layer. We search because that's what minds do, not just to find, but to reach through time, through distance, through possibility. The same curiosity that sends probes to other worlds sends thoughts into the past, asking who else might have stood where we now stand, looking up, wondering, listening. And you, right now, wherever you are, whenever this reaches you, you're part of that, part of the long thread that ties questions to silence and silence to story. Even by listening, by following this trail of thought through the dark, you're participating in something deeply human, or perhaps something universal. Because sleep, too, is a kind of deep time, a letting go of the surface, a sinking into layers. And when you drift off tonight, you'll be entering a space not so different from the one we've been exploring, quiet, vast, unlit by certainty. And maybe, just maybe, somewhere in that stillness, the minds that came before, if they ever came at all, will meet yours in passing. Not with answers, but with company. So rest now. Not because the questions are over, but because you've carried them far enough for one night. The past will wait. The earth will keep turning. And whatever came before, whatever comes next, you are here now. Sleep well, traveler in time.